Hello, my dear students and the rest of the learners. Welcome to part 23 of a 95-part series of tutorials in object-oriented programming in C++, in which we are looking at the implementation of objects and classes, with our focus being on free store, or what we call dynamic objects. My name is MemJM, or you can simply call me Emily Swap. A free store is a pool of memory available for you to allocate and deallocate storage for objects during the execution of your program. The new and delete operators are used to allocate and deallocate free store, respectively. The three ways of creating free store objects include: number one is creating single object without initialization. For example, we can declare a pointer called myIntPointer of type integer that will point to an object or a new object of type int. In other words, if we want, for example, to have a variable of a certain type or a section of memory being set aside temporarily to hold a value that you want, for example, to be pointed to by a pointer during execution, then you can be able to declare it when you need it, as you can see. So this statement declares a pointer called myIntPointer that will point to an object or a new object of type int. And remember, once you are done with such an object or such a variable, you can be able to erase it and set its memory free, as you are going to see. So in this case, you are creating a variable for use only when needed, and then you'll be able to dispose it once you are done. The new, in this case, returns a pointer. You can then assign a value to the object pointed to by the pointer, for example, as follows. So in this case, you can see you can have that variable in which you can store a value like 5. Or in this case, instead of really having a separate variable to hold the value 5, once you have declared your pointer that will point to an object, as you can see, you can then be able to assign a value to that object that is being pointed to by the pointer, for example, called myIntPointer, as you can see. So in this case, we are assigning value 5 to the object being pointed to by the pointer. Secondly, you can have what we call single object with the initialization of the object. For example, you can be able to declare, or you can have a statement like this that mostly is creating an object or a new object and initializing it to a value at creation time. So in this case, we are creating an object of type integer, and then we're initializing that object with a value for the 2, and then we are assigning the address of that object to the pointer called myIntPointer, which of course is of type integer. So in this case, this statement is performing the task of initializing the pointer or initializing the variable of type integer with a value, and then we are making the pointer, the newly created pointer, to point to the address of the object. And in this case, what I'm calling the object is the variable. So the memory that has already been set aside, a new memory that has been set aside to hold the value of type integer, is being assigned value for the 2 during creation. And then at the same time, the pointer that is being declared is also being initialized to the memory address of the new variable that we have already created of type integer and in which value 42 is stored. And therefore, because my int pointer or my pointer called my int pointer has been initialized to the address of the new variable, then it means that we can indirectly access the value stored in this new variable or in this variable directly or indirectly using the pointer. So you can output the value of the object being pointed to by the pointer as follows. So you can have cout, and then what are we outputting? We are outputting the value that is stored in the newly created memory or in the new variable indirectly. In other words, when we have a statement like this, it directly accesses the value of the memory that is being pointed to by the pointer called my int pointer, and then that value is being displayed or output on the screen. We can also have an array-like structure. For example, we can create a variable which is an array or is of type array. Like as you can see in this statement. So this statement, or in this statement, we are creating or we are setting memory location assigned of type integer, which is an array that is going to hold at least a number of objects or a number of variables of the same type. In other words, with this statement, we are creating or we are setting a new memory location assigned to hold an array composed of 3 values which are all of type integer. And then these 3 consecutive empty integer objects that have been created, or this array memory location that has been created, is being, or in other words, this statement here is declaring a pointer called my int pointer, which is of type integer. And then at the same time, this my integer or my int pointer is being initialized with the memory address of the object, which is of type array that we are creating. In other words, my dear students and the rest of the learners, what we are doing is that we are creating a free store. We are creating a memory location which is of type integer, and it's an array that is going to be composed or that is going to hold 3 values, which are whole numbers. And then we are initializing my pointer or the pointer by the name, my int pointer, with the memory address of the newly created memory, which is of type integer. So this statement is having or is creating 3 consecutive integer objects, which I'm referring to as an array, and the address of that array is being assigned to the pointer called my int pointer, which is of type integer. So the pointer by the name my int pointer points to the first of the objects in the set and can be incremented to point to the next object. My dear students and the rest of the learners, for you to be able to understand exactly what I'm explaining, you can go to Emily Swap ICT YouTube channel and then listen to the presentation in C++ programming series in which we talked about pointers. You can then assign a value to the first object, for example, as follows. So this statement, the last statement on my screen here, is assigning the first value to the array, the first value to the array that we have created. Note that this array is going to hold 3 objects of type integer. And therefore, because our pointer called my int pointer has been initialized with the address of the array or the memory address for the array that we have just created, then you can use the pointer to indirectly assign a value to the memory or to the array that we have created. And therefore, in this last statement, we are assigning value 10 to the array that we have created indirectly through the pointer. This is because the pointer has already been initialized with the memory address of the array that we have created. And when we are initializing a pointer with the address of an array, usually it is the first address for the first object that is normally stored in the pointer. And once the pointer is able to access the address of the first element in the array, then it becomes very easy for us to progressively, or for the pointer to progressively access the rest of the elements in the array. And therefore, this statement is assigning the first value 10 into the array of type integer that we have created. You can also assign a value to the second and even the third elements. So what you're supposed to do is, because the pointer called my int pointer has been initialized with the first address of the first element in the array, then for us to be able to access the next element in the array, we just need to increment the address of the pointer with 1. And that's what we are doing. And then we are assigning value 15 to the second element. This is because once you increment the pointer, once you increment the address being accessed, or once you increment the number of elements, or once you increment the current element with 1, of course, it means you are going to move on to the next element. And therefore, what this statement is simply doing is that it is incrementing the pointer. It is incrementing the pointer with 1. So if the pointer was currently accessing the first element, which is element number 0 or index 0, if we increment 0 with 1, it is going to give us 1. And therefore, in that case, it simply means that if we increment 0 with 1, it is going to give us 1. And therefore, the pointer will point to the next index in the array, which is index number 1, which of course is element number 2. And therefore, we are assigning value 15 to the second, or to the memory in the array that is being pointed to by the pointer, whose index is 1. And we can still do the same for the third element. If we wanted to assign a value to the third element in our array, what we are supposed to do is to still increment my int pointer with 1. Currently, the pointer is pointing to the address, which is address 1 or index 1, which of course in memory, it is element number 2. Therefore, if we increment that with 1, the new index will be 1 plus 1, which will give us 2. And therefore, index number 2 in our array will be element number 3. And therefore, we are going to assign, or we can assign another value to element number 3 by having the statement, as you can see, but then you can even say my int pointer plus 2. If you say my int pointer plus 2, that will be address number or index number 2, and that is element number 3 in the array. You can, of course, delete a free store object. Remember, free store objects is simply a situation where you create objects or you create variables when you need them, and you dispose them or you delete them once you are done. And therefore, that continuously sets memory for use. Even if your computer or your device is having a little memory, you can manage it using the free stores, where you only create or you declare a variable when you need to use it, and then once you are done, you dispose it. That's the logic behind free stores. So once you are done with a variable or an object, including a class, you can always dispose it or delete it. For example, we can delete the pointer that we have already been using in the cases I've explained, using a statement or using the reserved one, delete. So delete what? Delete the pointer. Delete the memory that has been set aside for the pointer. And therefore, a statement like delete my int pointer simply deletes a single object. Which object? The object which is a pointer. The pointer that we've been using, the pointer that we've been using to point it to the memory that has been set aside for a variable, whether it's a single variable or it is a variable of type array. You can also delete a complete array structure. So if you want created or you want declared a pointer to point to an array, then you can still set that memory free by deleting completely the array structure, as you can see. The square brackets, of course, indicates that our pointer is pointer of type array. I still repeat, for you to be able to remember or to understand what we are calling a pointer of array or array of type pointer, then go through MLSwap ICT YouTube channel video on C++ programming, in which we talked about arrays. To make a single object to grow, just increment the pointer and use the new operator to assign the same object type from free store to the incremented pointer. I've already talked about how we increment the pointer to be able to access or assign various elements in an array. Further, increment and use new operator. You can always increment and use new operator to increase free store, as we have seen. You can define your own versions of new and delete for a class by overloading them. You can declare the new and delete operators for a class by overloading them. You can also declare the new and delete operators with additional parameters. When the new and delete operator, or when the new and delete functions operate on class objects, the class member operator functions, new and delete, are called if they have been declared. If you create a class object with a new operator, one of the operator functions, that is, for example, operator new, for a single element or single variable, or operator new when you're dealing with an array, if they have been declared, is called to create the object. An operator new, that is to declare or set a memory location for a single variable, or operator new that is meant to create or declare an array structure for a class is always a static member, even if it is not declared with the keyword static. It has return type void. Note, this return type is for a pointer. So it has return type void, type of type pointer, and its parameter must be the size of the object type and have type standard, or the type that we write as std with the scope being size t. In other words, let me correct that statement, because understanding how to interpret statements in programming is key. My last statement here, which has std and the scope resolution operator size t, simply means that size t is within the scope of standard or std. So it cannot be virtual. The type size t and the scope standard is an implementation dependent and assigned integral type defined in the standard library header cstd def, that is, for standard library or standard definition library. So size t or size underscore t, that function is defined under the standard library header cstd def. And therefore, if you are going to use size t, then you must have the preprocessor directive cstdf or cstddef within your program. When you overload the new operator, you must declare it as a class member, returning type void of type pointer, with its first parameter being of type size t, whose scope is std. You can declare additional parameters in the declaration of operator new for a single variable or operator new for an array structure. Use the placement syntax to specify values for these parameters in an allocation expression. The following example overloads two operator functions. So we have this function or this statement here, which overloads the default new operator by allocating memory with the C function malloc and drawing a string if malloc fails. So you can see we are using the reserved ones operator and the new function. And we have size t, which we have already discussed. And of course, mem size is, of course, the name of our variable. You can call it even identifier if you want to. We also have a statement like this, which is, or in this case, in which the function takes an additional integer parameter by the name allocation. This function implements a very simplistic memory manager that manages the storage of up to 3 objects. Then the delete operator destroys an object created by the new operator. The operand of delete must be a pointer that is returned by the new function. If delete is called for an object with a destructor, the destructor is invoked before the object is deallocated. If you destroy a class object with a delete operator, the operator function, operator delete, for a single element or a single variable or object, or operator delete for an array structure, if they have been declared, is going to destroy the object. An operator delete function, or that's for a single a variable or operator delete function, which is an array for a class, is always a static member, even if it is non-declared with the keyword static. Its first parameter must have type void pointer, because the operator delete function and the operator delete for an array structure have a return type void. They cannot return a value. The following is therefore a sample program that indicates how to free 400 bytes of memory. So in this program, you can see we have the standard library, cstd-lib, and we also have the preprocessor directive iostream. We have using namespace standard. I hope you know the meaning of these statements, because this is part 23 of the series. If you don't understand what using namespace means, I would kindly request that you go through the C++ series of presentations. There are 7 series of presentations in C++ programming, and also ensure that you move on and progress to listening to the series on the object-oriented programming in C++, so that you can get clear understanding of this presentation and the meaning of these statements. So we have our class. My class is called class X, and it has public members. So we have the first statement here, which is void operator new size t mem size draw post car of a type pointer. Then, because that is a function, we have the definition of that as follows. We have a malloc mem size being assigned to pointer p, or the function, can you call it pointer p, which is not expected to return any value. So it is void. So void pointer function. So this is a void pointer function. Then we have the statement, if the value in the pointer is equal to 0, in other words, if there is nothing, if there is no value being pointed to by the pointer, or if there's no value in the memory for the pointer, then throw or return the message failed. So return the message malloc function failed. Otherwise, if there is a value that has been generated, return that value as p, or as the function. Remember, a function within a class, undefined in a class, has a special name which we call a method. So that's the end of that function. We also have another function, that is function delete, which of course is also not expected to return any value. So this function delete is also expected to receive a value of type pointer. And what value is this? This value is also a function. So it's a pointer to a function that's not expected to return any value, because that is void. And then the body of it is to display the message that the operator delete, which is under the scope of X, is, in other words, Let me rephrase. This statement is going to display the message X scope resolution operator, operator delete, void. So this is simply a statement which is expected to tell the user what value is going to be displayed. So this function called delete, the function called delete, whose scope is X, is going to, or that is receiving a value of type void, is, of course, at the end of the day, expected to set some memory free. However, my dear students and the rest of the learners, let me not complicate this statement. This statement will just display the ones enclosed in double quotes on your screen, and the cursor will move on one line. Just that. But it's good for you to know how to interpret it. Then next, we have free. We have the function called free. That, of course, is going to receive the value that has been received as P. So whatever value that has been received through the operator delete parameter will then be received as a parameter in this function called free. And that will be the end of that, or that's the end of that function called delete or operator delete, which is not expected to return any value. So what we need to be asking ourselves for now is, what is this? What is this operator delete going to do? We know the operator delete is supposed to set memory location free. So we have the next class called class Y, which has a member called filler. And this member called filler is of type array. This array is expected to be composed of 100 elements of type integer. Now, this can be adjusted. This figure can be adjusted, or you can adjust this value to free various memory amounts. And then we have a public function or a public member. We have a public member here who are two arguments. And these members are functions or methods, one called delete, which of course is receiving parameters, and these parameters, or these two parameters, is mem size. One is mem size, and then you also have P. And they are expected to draw a parameter of type car of type pointer, and that value is constant. I would like you, my dear students, and the rest of the learners, to learn how to interpret such a statement. And then the body of this function is simply going to display or output the following. The statement or the string of characters is freeing. Freeing what? Mem size. Mem size is the number of bytes that are going to be set free. Now, these bytes are those ones which have been received through the operator delete function and the parameter mem size, which is of type size t. Am I really giving that explanation correct? challenge. Anyway, the cout statement. The cout statement is displaying the message is freeing. So those characters will be displayed in the screen, and then the compiler will pick the value that has been received as and mem size as parameter. The value stored in the memory location called mem size, and that will be displayed on the screen, followed by the ones bytes or byte. And then the cursor will be dropped one line below. And then the next action will be set the memory, to set the memory pointed to by the pointer, or to set the memory for the pointer called P free. So once that is done, that will be the end of that function. And then we end the class. We move on to the main program, main function, int main. And under it, we have the statement. We have the statement, or we have a number of statements or declaration statements, whereby in this first one, we are declaring a new memory location, which we are calling X. And we are initializing the pointer called PTR with the address of our newly created memory. And this pointer will be of type X. And you know what X is? It is the class X. This one here. So that's an instance, is an object, will be an object of type class. And therefore, this statement here is declaring a new object, a new free store by the name X, and we're initializing a pointer, or we are creating a new object of type class X, a new object pointer of type class X. So the new object by the name pointer of, or instance of type class, pointer of type class, is being initialized with the memory address, or with the address of the newly created free store, which we are calling X. And then once that is done, the next statement here is to delete or erase, the pointer, erase the memory location that has been set aside to be used by the pointer. The next statement is similar to the first one. The second one, we are also creating a new free store called Y. And then we are initializing, or we are also declaring a pointer, which I'm calling Y pointer. So Y pointer is a pointer of type class by the name Y. So we are initializing Y pointer, the object is called Y pointer, which is an instance of class Y with the address of the new object, or the free store that we have created called Y. And then once we are done with the use of that free store, we delete it using the reserved word or the function delete. So, my dear students and the rest of the learners, you can see that we are creating a free store and then we delete it once we are done. So once that is done, once we do that, that will be the end of our program. So what we expect is once this statement is executed or invoked, the compiler is supposed to go to class Y or to class X. It's supposed to come to this class X here and perform the tasks here. Once it is done, and then we invoke the function called delete, we expect that function to erase that object that we are calling PTR. And how will that work? Already we have the operator here, delete. So this operator or this function called delete will perform its work of erasing or cleaning that object that we have already used. From there, it's going to proceed and come back to this next statement. Once this statement is invoked, then the compiler will go to the class called class Y, perform the tasks here, and then, of course, once this statement has been executed and completed, the control will be brought back to the main function, and then it will invoke this other function for delete. So delete, once this function is executed, the free store or the object that we are calling pointer to class Y, that is the object for class Y by the name Y pointer, will be erased. And that will be the end of the program. Now let's see how we can decode this program. Let's see how we are going to code or how we can decode this program in C++ and see the results that we are going to get. But generally, once we execute this program, what we expect to get is we expect our program to generate the output that will be similar to the following. So first of all is this statement. This statement will be displayed telling us the operator delete, that the operator delete has been able to set the following memory free. So operator delete, which is under the scope of class X, will be able to set 400 bytes of memory free. So this is what we expect to see. So the statement delete pointer, this one, the statement delete pointer, this one, the statement delete pointer calls the operator delete, of course, which is a function, which is receiving a function, another function of type void, or that's not expected to return any value, or type pointer, and the scope or its scope is X. So the statement delete pointer calls operator delete, whose scope is X, while the statement delete Y pointer, this one, calls operator delete, which or whose scope is class Y, whose scope is class Y. So let's code this program. Let's just copy this program as it is, and we paste it in C++ editor, and then we see what we are going to get. So what we are going to do is let's start our C++ program. So, and remember, in this series of presentations, I'm making use of Visual C++ 2010. So I'm going to click on New and then Project. It is Win.2, Win.2 console application. And then I'll give it the name. I'll give this function or this program the name, a name that we can be able to remember. I'll call it a free stores. So let me give this program the name free stores. Free stores. And then let's proceed. So under source files, I'll right click, and new item. Remember, my dear students and the rest of the learners, what is important here, whatever activity I'm carrying out is to load my end data. So based on the C++ version that you have in your computer, you can follow other steps, but what is important is for you to be able to start a new file or a new program. So it's not a must that you follow the steps or the procedure as I'm doing. What is important is for you to know if you're using any other version of C++ program, just have or start a new file or a new program. And once you're in this editor here, this is where now you write your program. So in my case, if you have this program with you, if you have copied this program in your exercise book, just type it on the editor for C++. But if you have coded it in, for example, word processor or notepad or wordpad, you can just copy this program and paste it in your editor. For example, in my case, I'm going to copy this program. I have already written it in my Word. So I'll just copy this program that I've already explained to you. I'll copy my program, and then I'll come to my editor. That is Integrated Development Environment for my C++ IDE editor, and I'll paste it there. So that's my program. That's my program. So you can either copy yours and paste here, or you can directly write it here, word for word, but it's advisable. Always write your program on a piece of paper and also dry run it on that paper. Check for any errors that may be there. And once you are done, then you proceed and use or load your program, your programming language, C++, and code it or transfer that program of yours in the editor. So once your program is here, what you need to do is to save it. Save your code. Remember, this is source code. Once you have coded in Visual C++ 2010, to compile your program, you click on Build, then Build Solution. However, if you're using another version of C++ program, you can still compile it. You can click on the respective menu, and then you compile. You click on Compile. So our program has been compiled, and we can see here it has succeeded. It's successful. There is 0 fail, 0 update, and a 0 skipped. So that means that our program is okay. It has no syntax errors. Now let's execute. Let's run our program. If you're using another version, just click on Run. Now in C++ 2010, you click on Debug, and then because our program has no errors, we are going to click on Start Without Debugging, and then we see the response we are going to get. Good. You can see what our program is displaying and what has been done. Just as I said, this statement here was meant to display the message, as you can see on the first statement here, that the operator delete which is having a parameter of type pointer function, is freeing 400 bytes. So this is freeing is in the second is being generated by the second function under class y. So the first one, the x, the operator delete underscore class x. You can see this is class x, and this function delete is under this class, but is freeing, the section for freeing is, or this message here, the C out here, is from class Y. So what is key for you is to note here that the function delete, operator delete, is deleting or setting free for 100 bytes, for 100 bytes of memory. And that's simply what this function or this program is doing. So you press in the key, continue, and we are done with our program. We are done with our program. So this program is simply indicating how to create free stores, use them, and delete them when done. So once we have known how to make use of free stores, then we are good. In object-oriented programming, it's always important for you to know how to manage memory so that even if your memory is little, you can still be able to use it up to the edge and your computer does not hang. So you have seen that we have gotten this kind of output from our program. This is exactly what we have gotten. So the result of trying to access a deleted object is undefined because the value of the object can change after deletion. So because free stores, you create memories when you want to use them and you set them free when done, even if you are making use of the same name for an object. The content for that object will always be changing based on what you are assigning to it. So the result of if you try to access a deleted object, you are always expected to get something different or a different value. If the new and delete functions are called for a class object that does not declare the operator functions new and delete, or they are called for a non-class object, the global operators new and delete are used. Remember, new, the operator new is for creating a new object or a free store. And delete is for erasing it, setting that memory free. The global parameters new and delete are provided in the C++ library. In other words, if you have not coded the delete and the new operators specifically within your program and defined them the way you want, generally, there is what we call the predefined functions that are already stored in the C++ library. And which library is this one? It's the standard library that we have seen. And therefore, if you do not define, you don't redefine your delete and the new operators within your classes or within your program, once you use the word new or delete within your function or within your program, the compiler will invoke the new and delete functions that are already predefined in the respective C++ library that we have already seen. So the C++ operators for allocating and deallocating arrays of class objects are operator new for the array, and delete when you want to erase that structure. In other words, you can set a free store which is of, or you can declare a free store which is of type array using the new operator, and the syntax is as you can see. And once you are done with that object, you can also delete it using the operator delete, whose syntax is as illustrated. So you cannot declare the delete operator as visual. You cannot declare delete operator as visual. If you don't remember what is the meaning of visual, I kindly request that you go through the previous series of tutorials from part 1 to part 22 in object-oriented programming series so that you can be able to come across the presentation in which I talked about visual or visual functions. So we are saying that you cannot declare the delete operator as visual. When you overload the delete operator, and you are going to see some overloading in this presentation, you must declare it as a class member returning type void with the first parameter having type void, which is type pointer or a pointer of type void, a pointer which does not return any value. A pointer function that does not return any value. You can add a second parameter of type size t to the declaration. You can only have one parameter delete for a single object or for an array structure for a single class. And with that, my dear students and the rest of the learners, we have come to the end of part 23 of this series. You will continue gaining more understanding about the object or about the delete and the new functions, and also the visual or the visual functions as we move on in this series of tutorials. So you can continue to part 24 of 95 of this series, in which we are going to be looking at static objects. In this presentation, we have looked at dynamic objects, or what we are calling the free store, those which you create when you want to use them and you erase them when you are done. But in the next presentation, which is the presentation number 24 or part 24 of 95, we are going to look at what we call the static objects in the implementation of objects and the classes. Congratulations for learning part 23 of 95 on free store in implementation of objects and the classes in object-oriented programming. You can access videos for the other parts in object-oriented programming series, as well as other computer or ICT videos by clicking or tapping on MLSAP ICT YouTube channel below this video. Remember to subscribe to the channel by tapping on subscribe button below this video in YouTube if it's not currently reading as subscribed. You can also join as a special member by clicking on the join button below this presentation to join this channel for special offers as a special member. For any further correspondence, kindly write it to us through the email mlswap@gmail.com. Thank you very much for listening to me, and God bless.